Well, g'day guys. I've got a class, or some classes, doing a test next week on surface area and trigonometry. So I thought I'd put together some practice questions for them, and whack them up on YouTube or wherever it is that you're accessing this, and see if it can help anybody else. So I don't know how long this is going to take. We've got a few to get through. I'd like you to pause it, maybe if you're doing this for test review. Just pause it, when the question comes up, have a go at the question, see if you can get the solution before I walk you through my solution. So yeah, just get comfortable. We're here for a while. I got a cup of tea, we're good to go. So let's get started. So in this test that you're going to get a formula sheet that looks like this. So these things you don't need to memorize. They'll be given to you. You need to know how to use them, but you don't need to memorize them. So there's some area formulas here, a little sort of phrase to help you remember your trig ratios, and some volume stuff. So let's get into some questions. All right, something like this. What is the area of this shape? Now that's a weird looking shape. If I look at it, it's kind of nothing that I kind of recognize. But to find the area, in other words, the space inside of the shape, there's a couple of ways I could do this. I could chop this into two pieces, like a rectangle and a triangle, make a composite shape out of it, and work them out separately and add them. Or I could do this actually in one bit, because this shape is actually a trapezium. Now, you might think, well, that doesn't look what we know to be a trapezium. Something like this that has a pair of parallel lines, and then the other two lines that are not parallel. But that's exactly what I've got. The top and the bottom here are parallel, and the sides are not. Just because one of them is sort of weird, it's still a trapezium. Okay, it's just that I've sort of pulled in one of the sides. So we have a formula, and that was on that formula sheet that we just showed you that you'll have during this test. The area of a trapezium is half times the height of the trapezium outside of A plus B, which are the tops and the bottoms. So all those letters, let's look at them on a trapezium and see what they look like. H, or the height of the trapezium, is the distance between the parallel lines. So that's this value here. On my diagram, this is 7 meters. The A and the B are the top and the bottom. Now you might like to remember that as the above and the below, the A and the B. So in my formula, if I know the values for H, A, and B, I can substitute them into my formula, and that's what it looks like. Half times the H, which was the height, outside of A plus B. Now, if we whack that in our calculator, and luckily I just happen to have one handy, let's pull that up. Let's clear that, and clear all of that. And so I'm going to put this in. Now, a couple of different ways you could do this. You could... So let's have a look. You could do half as 0.5, but I'm going to just do it as a fraction. I'm going to do 1. I'm going to do it just as I see it. A half. I'm going to hit the side button, so I'm get my time sign next to it. 7. I'm just going to open the brackets and do it exactly as we see it. 8 plus 14. Close the brackets. There's my keystrokes up there, and if I hit equals, I get a value of 77. Which is great. That's the area of my trapezium. But don't forget, area, the units are always squared. So my units were meters for all of these measurements, but it's an area, so it's meters squared. Now, I'm going to show you the way I do trapeziums. Now, you can remember the formula and use it, but for me, the result comes from just averaging the top and the bottom, and then multiplying it by the height. So the average of something is when we add them together. So add the tops and the bottoms, divide them by 2. That gives me the average of those two, and then multiply it. So 8 plus 14 over 2 is 11 times the 7. Gives me the same answer. So either way, do what works for you. I've got a shape here that's shaded in part of it, but part of it's being chopped off, and I'm asked to find the area of this shaded piece. There's a couple of ways you could do this. I'm only going to go through one. For me, I look at this and think, well, if this was a full rectangle, I could work that out. Well, then I've just got to subtract or take away the bit that's been chopped off. So if I can work out that area, I can take that away from the full rectangle. Now, if I have a look at this, it's 18 centimeters across the bottom, 17 across here. That must mean this bit is 1 centimeter. So this is the bit I'm trying to find. If I can chop off that red shaded piece, then I'm good to go. Now here's an important thing. This diagram is an example of something really important. In a test, don't be fooled. Like, things might not be to scale. Like that does not look like 1 centimeter. Like if that's 17, there's no way that could be 1. Always trust the numbers. The diagram could be rubbish. In this case, it is. It's a bad diagram. So 17, if it's 18 all the way across and that bit's 17, this bit has to be 1. Doesn't matter if it doesn't look like 1. Trust the numbers or the symbols, whatever you're given, they override the logic or the diagram. Okay, same with this. If this is 12 from top to bottom and this bit is 11, that only leaves me 1 centimeter for this piece. So I've got a triangle that is 1 centimeter by 1 centimeter. Once again, the diagram doesn't look right, but I'm going with the numbers. The area of that triangular piece is half times the base times the height. That's our formula for the area of a triangle. So I can do that. Half times one side times the other gives me an area of 0.5 centimeters squared. Now I'm just going to chop that off the full rectangle. Now the rectangle is length times breadth, so one side times the other. That's the area of a rectangle. So if the whole thing was one big rectangle without the piece being chopped off, it'd be 216 centimeters squared. I'm going to take away from that the 0.5 that's being chopped off. So the area of the shaded bit is the area of the full rectangle minus the triangle piece that we chopped off. 215.5. Don't forget to put the units, which was centimeters, but it's area, so it's centimeters squared. All right, well done. The area of this circle, and the formula for the area of a circle is pi times r squared. Now r is the radius. That's the distance from the center of the circle to the edge. So in this case, my radius is 8. All I do is I substitute that in. Now, if you've been in any of my classes, you'll know that I go a bit crazy about this, but I always like people to put a little set of brackets where they're substituting. So I've taken out the r and I'm going to replace it with a set of brackets, and in those brackets, I'm going to put my value, which was 8. Now, a couple of reasons for doing this. One of them is that you can put that straight into your calculator and it will get it right. It will recognize what you're trying to do. You're trying to do pi times 8 squared. Okay, the brackets help the calculator understand what's going on. So let's put that in. Let's clear everything we've got here. Clear this. And I'm just going to put it in exactly as you see it. Now to get pi, we hit the shift button first, then this button down here, because see the little, I don't know if you can see the little yellow pi symbol there. So we hit shift, then this times 10 to the x button gets me my pi symbol. Open bracket, 8, close bracket, x squared button gets me the squared symbol. Hit equals, and I've got a value of 201. All right. Now, you'll notice I left that in its first case, 8 squared is 64. You could leave that as 64 pi, you'd still be correct. But if we do that in the calculator, using that bit there, we're going to get 201. Okay, good job. Just be careful though. In these kind of questions, sometimes instead of the radius, you might be given this distance right across the circle, which is a diameter, which is 2 radii. Okay, it's a radius and another radius, 2 of them. We call them radii. So in this case, the r value, the radius, would only be 4. So just be careful in the question. Just check, am I given a radius or am I given a diameter? This grey section here represents 270 degrees of a full circle. So what fraction has been shaded? One circle, one whole revolution all the way around, hopefully you remember, is 360 degrees. So I'm going to simply say, look, I've got 270 out of those 360, and I'm going to put that as a fraction. Now, I could leave it like that. The question might ask you to simplify that, to write this fraction in its simplest form. Now, if you can't do that mentally, you can use your calculator. Let's have a look. Let's clear everything. I can put that fraction in. So here's my fraction button, and I'm going to do 270, hit the down cursor to go to the bottom of the fraction, hit 360, hit my equals button, and it comes up with my simplified fraction of 3/4. Excuse me, I'm going to have a quick cuppa. Now, if for some reason your answer came up like this as a digital, that's where you've got this little SD button, standard to decimal. Every time you click that, it will toggle between the decimal and the fraction. So I want 3/4. That is this written in its simplest form. 3/4 of that circle have been shaded. Surface area questions. These are probably one of the more challenging ones because there's no formula that you can just use. You're going to have to unpack this shape, and that's literally what we're going to do. We're literally going to unpack this shape. This triangular prism, we're asked to work out the surface area. Now, the surface area, if you were to spray paint this prism with a can of spray paint, would be all the stuff on the outside and the bottom that gets painted. Okay, so it's not volume because that's the space inside, but it's the outside faces the area, and we're going to have to work them all out individually and add them together. So here's the way I like to think of it. Here's the bit that the shape is sitting on. It's sitting on its base, and I'm going to just draw what we call a net. If I unfolded this, like if I cut this shape open, let's say it was made out of cardboard, and I laid all the pieces out flat, I would make the net. So we're going to draw the net. The bottom bit is 15 by 8. I can see those dimensions, so I'm going to draw a box. This is like if I was looking down on it from above, like straight down, like a bird's eye view, I'd see the bottom of it, wouldn't I, as 15 and 8. Now I'm going to take this face here, this large sort of rectangular face here, and I'm going to peel it out flat. And if I laid it out flat to the right-hand side, okay, it would be 19, because it's 19 this way, 8 this way. Okay. Now I'm going to do the same with the back edge. Like I'm just unpacking it. I'm going to lay this blue back edge down, and I can see it's 11 that way, and it's 15 across. So here it is here. Like I've folded those bits out flat. The only bits left now to fold out are the two triangular pieces, like the wings of it. So if I folded them down flat, if I folded this one towards me and the other one away from me, and I can see that the height of that bit, that part of the wing, is this bit here. Right? It's really hard because you kind of got to visualize this. So if I laid that all flat, that's what it would look like. We call that the net. Now the area calculation is I just go through each one of those pieces. I've just, all those 5 separate pieces, I've labeled them 1, 2, 3, 4, and 5, and I work out the area of each piece. The area of 1, now I know this is a rectangle, it's 11 that way, and it's 8 that way, okay, because I can see this height here is 8. So 8 times 11 is 88. Area 2 is 15 that way and 8 that way. So 15 times 8 for the rectangle. Rectangle 3 I can see is 8 this way and 19 this way. So multiply them together, I get 152. So far I've done the 3 rectangles, the area of part 1, area of part 2, and the area of part 3. I've got the triangle bits to go. Now the area of a triangle is half times the base times the height. So if I look at this triangle here, I'm going to take the base of 15, the height of 11. So half times 15 times 11. So it's like I'm doing the rectangle but halving it. Works out to be that. And the other piece is exactly the same size. So I don't even need to do the calculation. I just do another one of those. There's my 5 pieces. Now, to get my surface area, I simply add them all together. And when I do that, I get 525. But it's an area, so I put my units of millimeters. I'm sorry, that should say millimeters. It says meters, but it should say millimeters. Sorry if that confused you. And it's millimeters squared because it's an area. There was a bit of work in that, I know. Surface area questions do take a bit of thinking and a bit of time to do. Find the surface area. So once again, the spray painted bit on the outside, top and bottom and the sides of this cylinder. Now, this is a formula you are not given on that formula sheet, so you're going to have to memorize this. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. Memorize it. Jot it down, get some people to test you, because we're going to use it to work out the surface area. So, the r and the h represent the radius of the circular bit, so the distance from the middle to the outside, and the height, the distance between the 2 circular pieces, how high the cylinder is. So in this case, I can see I've got a radius. Now be careful, this is not 15, because 15 is the diameter. Halve that gives me my radius of 7.5. And the h bit is straightforward, that's the 9. So all I need to do now is to substitute those values into my formula. Now remember I said, I really like you to just, first of all, before you do that, put a set of brackets where the letters were. Now we're leaving the pi in there because that's a number. So we don't substitute the pi, but the r and the h's. There was an r there, so I've put some brackets. There was an r, h there, so 2 sets of brackets. Where the r was, I'm going to put 7.5. And where the h was, I'm going to put a 9. Now, once again, the reason I like to do that is you can literally put that in your calculator. Hey, what the heck? We got time. Let's do it. Let's clear that. Let's clear that. And I'm going to put it in exactly as you see it. 2 shift to get my pi. Open bracket. 7.5 close bracket squared plus 2 shift pi. Open bracket. 7.5 close bracket. Open bracket, 9, close bracket, hit equals, and I get 777.544. Let's have a look. There we go. This is a surface area, so it's centimeters, and it's squared. I don't know about you guys, but for me, that's really handy. If I can just do it with the brackets, I know the calculator's not going to get confused with order of operations and that kind of stuff. Just put it in as you see it. Listen, if you forgot the formula, you might be able to brute force this one out if you think about it this way. If you forgot the formula, just look at the pieces we've got. I've got 2 circles. By the way, you could stop there. That's your answer. This is an extra bit. If for some reason you didn't memorize this formula, what have we got? We've got 2 circles. Okay, so I've got 2 circles, and that's what this bit is. It's 2 lots of pi r squared, which is the area of a circle, pi r squared. And I've got 2 of them. It's 2 pi r squared. Now, the walls of this thing, if I was to like sort of cut this and peel it open, imagine it was a can with a label, and I cut the label and then peeled it open, I'd have a rectangle, wouldn't I? Now, the rectangle would be 9 centimeters high, so it'd be h, and the length of that rectangle would actually be the circumference of the circle. Now, circumference is 2 pi r. So that's where this bit comes from. 2 pi r times the height gets me the rectangle. I think it's kind of easier to memorize the formula, but if you get stuck, you've got a way out. All right, what is the volume of this triangular prism? Now, a prism is a 3-dimensional solid. It's the same shape all the way through. So if I cut this thing, imagine this was like a big sort of tent or a big block of triangular wood, and I cut it halfway across, it would still have the exact same triangular shape on the end. So this being a triangular prism, because we name them by the shapes on the end, if I have a look, this little red shaded bit here, that's my triangular face. I need to work out the area of that. Any prism, if I can work out the area of the shape on the end, that's going to be my first step, because then I'm going to use that in the formula. Now, you might have learned it as the volume equals the area times the height, or you might have learned it as the volume equals the area times the depth. So in my prism, that's this bit here. It's how far it is between the 2 ends. Okay. In this case, my height or my depth is going to be 9. So I want to work out this area first. It's always the first step. Get the area of the shape on the end. It's a triangle, so it's half times the base times the height. So half times 18 times 21 gives me an area of 189. And according to my volume formula, all I need to do with that, once I've got the area, is I multiply it by the depth of the prism. In this case, is 9. Put them together and I get 1701. Now, because this is volume, my units were centimeters, but volume is always cubed. Right? Remember we said area was squared. Volume is always the units cubed. All right, hope you're traveling okay. Don't forget, pause after each question before I start to do the solution and just see if you can do it. Let's move into some trigonometry. Cup of tea time. All right, I am going to show you Toddy's foolproof step-by-step process for doing these trigonometric questions. Now, some of you, I know, if you're anything like my students, you like to just rush ahead and just put this number here and this number here. I want you to slow down, because in a test, there's a lot going on in your head. You might be rushed for time. You need a process that is going to just make it easier, like less going on. The more you're trying to do in your head, the more likely you are to make a mistake. If you can jot things down step by step, you're going to be a lot better off. Here is the process I want you to follow for every trigonometry question. First thing, I want you to go through and label the sides O, H, or A. This is my angle that I'm given. This is the side that's opposite the angle, because it's not touching it. This is my hypotenuse, because it's the longest side, which is the one opposite the right angle, which means the other side is my adjacent, the one that is next to or adjacent to my angle. That's step one. Always label them, right? Next step is write out your phrase, SOHCAHTOA. Now, you might just want to do this once. It's on your formula sheet, but if it's not, you can write it out, because every time we do a trig question, we're going to refer to this. All right, let's have a look. Excuse me. Having a look at my triangle, I've got information about the opposite and the hypotenuse. I've got no information at all about the adjacent. So I can't use anything that's got an A in it. So scratch these two. It has to be a sine ratio because it's got opposite and a hypotenuse. My sine, and that's what the little SOH stands for. Sine is opposite over hypotenuse. So I'm going to create a fraction. Sine of my 42-degree angle equals, create a fraction, on the top is my opposite, which is 6, and on the bottom is my hypotenuse, which in this case is m. We are most of the way there now. We're nearly done. The little shortcut. If you get to this point and the letter or the unknown is on the bottom, you swap these two. You swap the trig ratio with the letter. You just swap places. Literally just take the m, bring it up to here, bring the sine 42 underneath, or the cos or the tan, whatever it is that you've got here, swap spots. Okay, and now that's something I can put into my calculator. 6 over sine 42. We're going to do it because I want you to be careful of one thing. So let me just clear that. Let's put it in. Our sine button is right here, so we just hit sine, and you'll see the calculator gives you a, oh, what am I doing? Let's clear that, clear that, clear that. I made a boo-boo. Sorry, it's 6 over sine 42. So I'm going to create a fraction, because I've got a fraction to put in. On the top is my 6, down cursor. Now when I hit the sine button, you'll see it gives me an open bracket ready to put in my number, 42. Be careful. At this point, you have to close the bracket. Okay? If you don't, you're going to get an error, right? Which we don't want that. So let's clear all that, just showing you why it's important to do that. I had a fraction, I had 6 on the top, down cursor, sine 42, close the bracket, and then hit equals, and I get an answer of 8.96. Okay, and I've just put some brackets there because your calculator is going to do it, so make sure you close the bracket. I'm going to round that off to 1 decimal place. Now, if I was to round it off to 1 decimal place, that is a 9. The next digit is 5 or more, so that would get rounded up to 9.0. I'll leave it as 9 for the purposes of this example. All right, that's my process. Label the sides OH and A, decide what my sine ratio is, create the ratio, and use the little tricks. That was the first one, swapping. This question's a little bit different, but the process is the same. I've got an angle, although this time I've got some degrees and minutes. We'll talk about those in a minute. Minutes are just part of a degree. If I took 1 degree and split it into 60 pieces, I've split it into 60 minutes. Okay, there are 60 minutes in 1 degree. Let's label it. I've got my hypotenuse, because that's the longest side, the one opposite the right angle. I've got the side that's opposite my angle, and that means this side is my adjacent, the one touching the angle. I've got my SOHCAHTOA phrase, right? Same steps as the last question. And I have a look and see which side do I have no information about. It's the opposite. There is nothing. I've got 22 for the hypotenuse. I've got X for the adjacent, but nothing for the opposite. So I can't use anything with an O in it. This is going to be a cos question, a cos ratio, because I've got adjacent and hypotenuse. Let's create the equation. Cos of my angle, which in this case is 33 degrees, 12 minutes, equals cos is adjacent, the A, over hypotenuse, so X over 22 in this case. Adjacent over hypotenuse. Now, we're nearly done. You'll notice this time, though, the letter, or the unknown, is on the top. So there's only going to be two things. It's either going to be on the bottom, in which case we swap them. If it's on the top, we take the number that's on the bottom. Instead of swapping, we just drag the number across to the front of the other side. So it'll come over here, right? My 22 will go from the bottom. I'll bring it over here, and this is what I've got now. X equals this. I can put this in my calculator. How do we get the minutes, the degrees and the minutes in? I'm glad you asked. Let's have a look. I'm going to clear all of this, and we're going to do it. 22, just as we see it. Cos, you'll see it puts a bracket, so I'm going to put 33. And I'm going to hit this button. It's the degrees, minutes, seconds button. I don't know about you guys, my students for some reason call it the bubble button. So the bubble button, we're going to hit it. It gives me the little bubble, which is 33 degrees. Now I can put the 12 and I hit the bubble button again. Now, it doesn't put the little apostrophe. It just puts another circle. But that is 33 degrees, 12 minutes. Don't forget to close the brackets. What we're going to do, I hit equals, and I get 18.4. I've worked out the value of this side. So have you. You guys are amazing. That was the two shortcuts. We either swap them or we drag them. Depends on where the unknown is. Make sure you know how to do those. There's one last type of trig question you get. In this case, we don't know the angle. For those last two examples, we didn't know the sides. But in this case, it's the angle we don't know. But the process is the same. Let's do Toddy's method. Label the sides. Hypotenuse. This is the side that's opposite the angle, and this is the adjacent. SOHCAHTOA. Write it out. Have a look. What don't I have? In this case, I don't have anything about the hypotenuse. So scratch the ones that have got an H in it. This is going to be a tan question. Tan equals opposite over adjacent. That's what the TOA stands for. So let's create our equation. Tan of my angle. Now I don't know the angle, but I know it's called theta. So I can put tan of whatever the angle is, theta, equals opposite over adjacent. So in this case, it's an opposite of 12. It's an adjacent of 15. All right. This is great. I've got to this point. Now, what do I do? To work out the angle, okay, we can do the shortcut way. We can just do the sort of, let's get straight to the answer way, which is this. We're going to use the tan, but we're going to hit shift first. So I'm going to shift tan and then put my fraction in. So on the calculator, literally it would look like that. Shift tan, and we'll do it in a second. But actually, what's actually happening, just so we know the actual maths behind it, if I take this tan and drag it across to the other side, because I want the angle on its own, I'm going to drag the tan away. When it goes to the other side, it becomes inverse tan. I'm going to tan to the power of -1. And I'm going to put these numbers in brackets. These were the ones that were already there. That's actually what's going on. But in terms of the calculator, we're just going to do this. We're going to go, let's clear everything. We're literally going to go shift tan, and you'll see that's where I get the tan with a little -1. That's this part here. It opens a bracket for me, and I'm going to put my fraction in. 12, down cursor, 15. Don't forget now, don't do this. Don't close the bracket there. You need to move the cursor across to the right before you put the bracket. So the bracket goes around the whole thing. Heat equals 38.6. We are almost done, because we're asked to find it to the nearest degree. Now this is a decimal. How do we get this into a degrees? Well, our magic bubble button, if we simply hit it, right? Every time I hit it, it's going to toggle between the decimal version of my degree and the actual degrees, minutes, and seconds. So in this case, 38 degrees, 39 minutes, 35 seconds, because a second is, there are 60 seconds in 1 minute. There are 60 minutes in 1 degree. All I need to worry about at the moment is this bit, the minutes part of it. I look at it because there's 60 of them. If this number is 30 or more, I round this up to the next degree. The degree part would go up to 39. If this was less than 30, it would stay as 38. In this case, I can see the 39 minutes is more than half of 60. It's more than 30. So I'm going to round it up to 39 degrees. You guys are doing an amazing job. We're nearly finished, so hang in there. Hopefully this is helping you. You may get some bearing questions. Now, be careful, because there are two types of bearings. You may have been taught about true bearings, which have got 3 digits in them, or compass bearings, and that's what this question is. In fact, the next couple of questions are all going to be compass bearings. So if you're not familiar with compass bearings, they're not that hard. Let me explain as we go through. What is the compass bearing? Underline the important parts here. It's a compass bearing, and it's Y from X. So if I start at X and draw a line that goes out to Y, so it's going from X out to Y. And that's what this line is here. It's X going out to Y, because it's going from X. I want to know the bearing of that line, but a compass bearing. So compass bearings are going to start with an N or an S. So I'm going to just put the rest of the directions on my compass rose here: north, south, east, and west. They only ever start with north or south. Is my bearing, is this line in the northern half or the southern half? Well, I can see it's in the top half, which is the northern half. So it starts with an N. Is it then on the west side or the east side? Okay, looking at this, I can see it's clearly over towards the west side. So at the end of my bearing will be a W to represent west. Now, the bit in the middle is a number, it's a degrees, and it is how far, if I start at north, how many degrees do I move towards the west? So if I started at north, how many degrees do I move towards the west? In this case, I can see that it's 60 degrees. Boom, we're done. There's our compass bearing. North, 60 degrees west. We started at north, we moved 60 degrees towards the west, and that is our compass bearing. Here's another one, another compass bearing. So I can see it's a compass bearing of B from A. So if I start at A, go towards B, what would be the compass bearing of this line? Okay, let's put the extra directions on. Now I can see, remember I said it's either going to start with an N or an S. We always do the north-south first. Well, this is clearly in the southern half, so it's going to start with an S. Is it then in the eastern half or the western half? Well, I can see it's clearly towards the right. It's clearly in the eastern half. So it's going to start with an S, end with an E, but the number in the middle, now be careful. If I start from S, how many degrees do I move towards E? So it's not the 55 because I've got to start at the S and I've got to move towards the E. It's this angle that I want. Well, if this makes it 90 degrees and that bit's 55, this bit must be 35 because they have to add together to make 90. So I started at the south, I moved 35 degrees in the easterly direction. That is my compass bearing for that line. Last question. I know it's been epic, but hopefully this is helping. All right, another trig question, but it's got a little bit of a twist thrown in. I've got to find ratios for these three things: my sine ratio, my cos ratio, and my tan ratio. But to do that, I'm going to need to know the length of my hypotenuse, because I'm going to need that for the bottom part of my sine ratio, because it's opposite over hypotenuse. Cos is adjacent over hypotenuse. Now I've got no information, but luckily this question gives me a hint. Find the missing side first. So I need to know the length of that. Hopefully you can remember back to maybe in year 8 somewhere you did some work on Pythagoras theorem. Now you might have learned it as c squared equals a squared plus b squared. If that works for you, go for it. I'm going to use that to find the length of the hypotenuse. Personally, I prefer to teach it like this. Let me pause for a second. Here's why. If I wrote the unknown x in there, that's not c. So if we use c squared equals a squared plus b squared, people get confused. They forget to square root at the end, blah, 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 blah. All I want to know is I want the hypotenuse. So I would prefer to teach it like this. The hypotenuse is the square root of one side squared plus the other side squared. If you ever end up in any of my classes, I'll explain to you why, because I'm not even going to go into it now. This is a way I like to remember it. If I want the length of the hypotenuse, I do the square root, and I just take the two sides, square them, and add them together. So the hypotenuse in this case is the square root of 6 squared plus 8 squared. Put that in your calculator if you need to. You're getting a length of 10. So we know now the hypotenuse is 10. Now I can go ahead and finish off the question. The sine ratio. Remember our SOHCAHTOA? Sine is opposite over hypotenuse. So I'm going to go through and label it. I always said label the triangle first. There's my hypotenuse. There's my angle. So this is the side that's opposite the angle, and this is the side that's touching or adjacent to the angle. So let's put them in. Sine is opposite over hypotenuse. So in this case, the opposite is 8. The hypotenuse is 10. 8 over 10. Cos, in other words, the C part of this phrase is adjacent over hypotenuse. So in this case, my adjacent, I can see, is 6. My hypotenuse is 10, 6 over 10. And tan is opposite over adjacent. There's my opposite. There's my adjacent. 8 over 6. Ladies and gentlemen, I think that's it. I don't think I've got any more questions to go through. We've covered a whole heap in this video. Hopefully it's helped, and I wish you guys all the best with your test, or just if you're just watching this for the hell of it, good on you. Well done. All right, cheers.